Thanks a lot. So, well, let me just guide you very quickly what I will be talking about. I will be talking about how Ukrainian energy infrastructure, especially our transmission lines, were damaged after the full-scale invasion of Ukraine. Of course, I cannot talk about every day of the damages, but we'll stop on just several critical moments. One, the day of full-scale invasion and how our transmission system operator managed the system running. Then I will explain what happened during the biggest blackout which happened in Ukraine and what our transmission system operator did, again, to recover from the blackout. Then I will be talking about winter attacks during 2022, 2023, when we did have a regular, it was not a blackout, but we were without the electricity, and our TSO, transmission system operator, had to manage somehow the generation to cover all the needs. And I will be also talking about how we were preparing to this winter in order to stay resilient. And also a bit about long-term plans and taking the lessons learned into account. So a bit about the situation and the level of attacks. We had more than 300 hits on energy assets. The main weapons were missiles and drones. There were more than 15 missiles attacks and more than 18 drone attacks on the energy infrastructure. But again, when we talk about one attack, it's not one missile, it's usually 20 up to 40 missiles. So usually we talk about more than 1,000 missiles and drones which attacked energy infrastructure. And in blue and red spots are actually to show you where different attacks were located. So what particular elements of energy infrastructure was attacked. And usually those are three typical elements of the infrastructure, either generation, usually thermal power plants or combined heating power plants, or high voltage transformers, or of course, transmission lines. Yeah, so a bit about damages for energy infrastructure, what we have now, is, in general, we have maybe 50% of energy infrastructure damaged or destroyed. You can see on the left graph what percentage of the different types of generations we still have if 100% of generation was before the attack. So we have a bit more than 50% of nuclear power plants generation still in place, and this is due to the occupation of our Zaporizhzhia nuclear power plants. We have lost a lot of wind generation because it is located in eastern and southern part. And as you see, thermal power plants and combined heating power plants, they were attacked, and of course they were damaged. In terms of damages to the high voltage network, it's more than 40% of damages. And the high voltage transformers, as I said, 45% damaged or destroyed. And here is a picture of how usually the destroyed high voltage transformers look like. And now let me move to the cases, how exactly transmission system operator reacted to different force majeure situation. So the day of attack, you can see it was 24th of February, actually in 4 days. We will have this the situation when it happened, the day when it happened. So the attack started at night, and you can see from the graphs how it impacted the general situation with the load curve. What was the reaction of the transmission system operator, which I think might be important for the companies? The TSO, transmission system operator, curtailed the renewables. actually, the previous panel discussed the sensitivity, how to say, or a bit of issues, yes, around the renewables, how they are dependent on the weather. So in case of force majeure, they also might be an issue. So you have to take them out of the system, because they you have to somehow balance them. So in our case in Ukraine, our transmission system operator kept nuclear power plant generation as a base load, but decreased the level of generation, and also used thermal power plant, coal-fired generation to keep and to balance the system. So I don't want to make a very far-reaching recommendations or lessons learned, but just to highlight that the need in highly maneuvered generation or flexible generation is really important to keep system running when you have such force majeure situations. Another issue was a blackout on November 23rd. This is a picture from the space. You can see how Ukraine looked on February 6th, or before the invasion, and what happened in November 23rd, when we really didn't have any electricity generation. It was a total blackout. And in addition, we also had a lot of cyber attacks on our infrastructure. So what was the response of our transmission system operator? And it is important to say that Ukraine does have a very well-developed network of electricity system, and it helped us. So the attack and blackout the goal of the attack was to isolate different islands of the system, different elements or parts of the system from each other. So, for example, the generation parts of the system could be isolated from the regions or elements of the system who demand the electricity. In that case, what our transmission system operator did, it used the highly developed network to reroute the electricity supply to different regions. So we tried to avoid the situation of creation of different islands through, again, the well-developed network. And maybe this is also a lesson learned for other countries and transmission system operators, the need in developing well-connected and well spread, let's say, electricity system. And maybe to add that our transmission system operator has a power system protection plan, which says that in case of emergency, including blackout, the system and how system can be restored within 4 hours. In that case, in November 23rd, the system was restored in 2 hours. And again, maybe what can be useful from our case and situation, the need in such protection plan and planning such situation for the future is also useful. Then the winter attacks, which happened during 2002-2003. The graph shows how we import and export electricity from and to the EU. You can see that before the October, when the attacks started specifically on energy infrastructure, usually we exported electricity to the EU. We had even commercial export, but then we stopped this and started to not only to use our own generation, but we had a need to import electricity from the European Union. We used from May 2023 to January 2024. This is just as an example. 25 times we asked for emergency electricity import from the EU. And again, maybe the short lessons learned from our case is that interconnectivity is important. So if it is possible to develop better connectivity between the countries, that could be something which can increase the resilience of the system for the future. What else we did during the winter attacks is started to create a possibility to have a spare parts and spare equipment for damaged energy infrastructure. Our government, the Ministry of Energy, also with European partners and international donors, they created so-called Ukraine Energy Support Fund. And this fund works the following. We have the companies, energy companies, who send requests to the government on what they need, what particular spare equipment they need. The government collects all these needs and share it with donors, with energy community and with other donors. And then international partners, in our case, we have a USAID project. They are trying to do a procurement of this equipment. Sometimes international donors, and especially if it's governments of other countries, they decide to do or to send the equipment in kind. So we just receive different types of transformers or cables or any other elements. What is it is important to say that when you plan such types of activities, it's not easy sometimes to find spare equipment. Yes, you cannot go to the market and just buy transformer on the market, especially if it's a high voltage transformer. In Ukraine, we usually use the high voltage transformers. Usually it takes from 7 months or more if you go and try to buy it and if you want to procure it from the production company. So this timelines also probably should be taken into account when utilities are trying to do their planning for such things. Just to continue this example with the Ukraine Energy Support Fund, after 1 year of more or less manual work between government companies, government and international donors, an electronic system was developed, which is making this communication between donor side and company side much more transparent and direct. So any donor who would like to supply to supply equipment, but also to provide money for procure some equipment, the donors can see where exactly these or that spare equipment landed, what company received this, see the reports and other stuff. That's something which increased transparency and I would say even trust. It also increased speed of communication. I know that some of the countries who had some disasters and some problems with their electricity system, they asked for to share the experience of this aid energy system. We'll be happy to provide more details if someone from the participants would like to know more about that. How we prepared for this particular winter, because we understood that this winter will also be not very easy for us. So the government decided to do 3 levels of protections, the passive protection, protection from drones, and protection from missiles. The passive protection, it's not very modern, I would say, one. It's mostly gabions, I believe it's in English, and everything which can physically protect some of the elements of energy system from physical attacks. You cannot protect high voltage transformers with such gabions, with stones. In that case, our government developed some special nets which covered some of the equipment. I also maybe would like to underline that there were a lot of discussions that probably transformers can be hidden or can be placed under the ground in order to be protected from different physical damages. But at least discussion in Ukraine showed that it's not always a good decision, because you have to take into account what happens with the transformers, how big is transformer, and other stuff. So sometimes this discussion demands much more careful assessment. And protection from the missiles. Of course, if you have substations, if you have thermal power plants, you cannot even develop a net. So in that case, we definitely need air defense systems to be able to protect the system from the drones and missiles, of course, attacks. A very short experience of one of our cities. You can see on the map that the city is located on the north of Ukraine. It is under the attacks from Russia, from Belarus actually, with missiles and drones. So what they did in a short term, first of all they developed or they tried to find some backup generation, which is usually a generators. But they are trying to supply any any boiler houses, water utilities, facilities, hospitals with the separate generators. In addition, they have developed switchover plan because sometimes you do need to switch from one object, one utility to another utility with the same type of the same generation. So in that case, such planning is really needed, and they helped actually. This planning helped very much the city, and they had modular boiler houses, so they can move between the districts of the city in case just part of the city was without the heating. To be able to solve the problem. In the long term, there are, I would underline 3 elements. One is the development of decentralized generation of electricity. And this is what I have to say, huge lessons learned in Ukraine for many communities and cities. And that centralized generation sometimes might be a risk for the resilience of the system. So decentralized generation is really important if we talk about resilience. Then, of course, decarbonization, and this in the case of that city is moving from gas to local biomass, and the local decarbonization plan strategy till 2050, when they want to, their vision is not to use the fossil fuels at all. How our government used all these lessons learned in the regulation, I will be very short. I'll just say that maybe to summarize this slide, 3 main elements. One is to allow more import from the EU. So everyone who can import should import. There is, of course, the question with the prices. But if you are a huge facility, if you are an industry and you need your electricity to get electricity very fast, that could be a possibility for you to have this electricity. Second is less licensing for any cogeneration plants or critical infrastructure, or so as little regulation as possible to install some additional critical infrastructure. And the third element is decentralized generation, as I said. So a lot of support from the regulatory point of view to establish and to develop decentralized generation at the local level. And to my final slide is how the Ukrainian government now is using the lessons learned for the strategic planning. In that case, in our case, this is National Energy and Climate Plan till 2030. Just a few points. We need to reduce the level of import dependency. Although again, the connectivity still is important, but dependency should not be in place. We do need increase of flexibility of national energy system, and of course, we are discussing now how to increase or improve the market coupling of Ukraine day ahead and intraday markets with European markets. And all these targets are reflected in our policies and measures regarding our Ukrainian power grids. I will probably stop here and will be happy to answer all the questions. Thank you.